everyone! Welcome to FistBump, and today is an especially hyped episode because today I'm going to teach you the theory of relativity, time travel, and science with a sprinkle of math for a theory about Peter Pan. Next thing you know, we'll be learning quantum physics from Bambi. Now, I was going to make a theory about how Neverland is a metaphor for heaven, but I decided to let your childhoods rest before I destroy it with my Arthur theory. But anyway, let's get into the theory. So unless you've been hiding under a rock for 64 years, yeah, it's that old, Neverland is a magical place where you never grow up. So is that possible? Well, yeah. The gravitational pull is a major component in the aging process. Say we had two guys, one named Ralph and one named Bob, because it's always Bob. Bob was on a spaceship, and Ralph was on the ground. It's scientifically proven that Bob's aging process and time will be a lot slower relative to Ralph's. What does that mean for us? Well, if the gravitational pull of Neverland is small enough, it just might be enough to slow down and virtually stop the aging process. So, how do we do that? As Miss Frizzle taught me, the bigger the planet, the stronger the gravitational pull. How do we know the size of it? Well, we don't. But we have the next best thing. Hook's ship, the Jolly Roger. Kinda. A life-sized model of it, and that is around 640 meters long. So with that, this picture from when they just entered Neverland, and lots of blittily blab math, we can find the radius. So using pixel measurements, we can find that there are about 9 pirate ships throughout Neverland. 9 times 640 divided by 2 equals 2,790 meters, or just 2.79 kilometers. That's almost nothing. That's even smaller than Israel, one of the smallest lands on Earth. Neverland is even smaller than the smallest town in Israel. Just to clarify, the Earth's radius is 6,371 kilometers, and the moon's radius is 1,773 kilometers. So is it possible that it would slow down time and his aging process relative to us to the point where it slows down so much that it virtually stops? Well, almost. There's just one teensy-weensy little humongous problem. We're not looking at the full picture. We were calculating the size of the Neverland when we should have been calculating the size of the Neverworld, which was never said or even implied the existence of it. So is that it? It's just impossible? Well, not necessarily. I won't give up hope. Maybe it wasn't what was there, it was the way there. Based on the movie, Neverland is the second star to the right of the moon and straight on till morning. And as I couldn't find the exact location of that star, there's a good sister location pun in there somewhere. It's somewhere between 93 million miles away and, drumroll please, 13.2 billion light years away. So say it's about 13 million light years away, and if it takes till morning about 12 hours, that means that he's going over 1 million light years an hour, sprinting way past the speed of light and fracturing time with him. And here is where Einstein's theory of relativity comes in. So let's take Bob and Ralph again, and put Ralph on a high-speed jet and Bob on his couch. So it is scientifically proven that Ralph would age slower than Bob. And that's even been proven, not with these guys, with clocks. Slightly less cool. They put one on the jet and one in the ground, And surprise, surprise, the one on the jet slowed down just as much as Einstein predicted. So what is this theory of relativity that everyone's talking about? Well, I'm not going to explain in depth because that would be too long, and frankly, I don't know. I'm only 14, so I'll just simplify it. Say there were two people, Bob and Michael. Oh, psych! What a twist! You thought it was going to be Ralph. Anyway, Bob was on a jet going at 317 miles per hour with a ball, and Michael was looking from below. Wait, so Michael can see through a plane? I don't know. Maybe Bob's Wonder Woman and he has the invisible jet. I don't know. Anyway, so if, say, Bob throws the ball at, say, 2 miles per hour, for him it's only going 2 miles per hour. But for Michael, it's going the speed of the plane plus 2 miles per hour. So 317 plus 2 means he's seeing it at 319 miles per hour. That is a massive difference. But say if Bob had a laser pointer and he points it at the wall. So for Bob, it's going at the speed of light, but for Michael, it's also going at the speed of light because you can't see faster than the speed of light.
And now to measure the speed of light. Boy, that's quick.
But then the laser pointer is way in front of where he sees it because he can't see faster than the speed of light. So based on this theory, when you approach light speed, time slows down for you to the point that it almost stops. Don't believe Einstein? Well, game theory said so too, so there's that. So if Peter Pan comes back often enough to listen to Wendy's stories, he will stay young forever. Awesome, right? Say it as a party if you ever end up talking about Peter Pan. I know that happens to me a lot, right? Go to parties.
But what do you think? Is it possible? I'm talking about the theory, not the party. Although I am pretty curious about the party now, too. Write your thoughts in the comment section down below. And also, subscribe if you aren't already to get weekly Let's Plays and a theory every other week. Also, I just taught you the theory of relativity, answers to time travel, and so much more in less than 15 minutes. If that's not enough of a reason to subscribe, I don't know what is. Don't do it for me. Do it for you. To sound smarter next time you meet your friends at a party. I'm just kidding. So that's the end of this video. Hope you like it. Let's fist bump, and I'll see you in the next one. Bye.